All right, day 2 of Unit 7 on similarity, and today we're going to learn about similar polygons. So just to review really quickly, if we have two polygons that are similar, they have to have the same shape and angles, but not necessarily the same size. So the size of two polygons can be different, and they can still be similar as long as they have the same angle. So if I look at these two parallelograms here, I know that angle A and D would have one angle measure. Let's say that's 100. And then C and B would have to have the same thing. So in this case, those would have to be 80. As long as this smaller parallelogram has corresponding angles that are the same measure as those in ACDB, then those two parallelograms are similar. Another way to determine whether two polygons are similar or not is to see if all corresponding sides are proportional using ratios. Okay, there's a lot of words there. Let me explain what that means. First thing I'm going to do is I'm going to figure out what the corresponding sides are. Right? So in this trapezoid at the left, first side I see on the top there is AC. So AC is going to correspond with the top side of this polygon on the right. So in this case is DE. AB is on the left side of the trapezoid, and so the side on the left of the trapezoid at the right is DF. CD corresponds with EG, and BD here at the bottom of the big trapezoid corresponds with FG, which is the bottom of the smaller trapezoid. Okay, those are corresponding sides. What would one side be if it was on the other shape, basically? Okay, now what I have to do is figure out the ratio between the length of corresponding sides. Okay, here's how I do that. So I said that AC corresponds with DE. And I see that AC is 8 units long, DE is 4 units long. So the ratio is 8 to 4, and 8 divided by 4 is 2. So I'm going to do the same thing with AB. I see that AB is 6, and its corresponding side is DF, which is 3 units long. 6 divided by 3 is also 2. CD is 6 units long, and it corresponds with EG, which is 3 units long. 6 divided by 3 is 2. And then last, I have the two bottom sides. BD is 12. FG is 6. 12 divided by 6 is 2. Okay, so then this question down here at the bottom, are these ratios all the same? The answer is yes. Right? The ratio between every pair of corresponding sides is 2. And so what that means is that trapezoid ACDB is similar to DEGF. And yeah, the letters are a little bit out of order yet there, but that doesn't matter. Okay, the first example using similarity. This person wants to use this picture right here, but they want to increase the size of it. And the only way it's going to work without distorting the image is if they find dimensions they can increase the size to that are the same proportion as the original picture in the red frame there. So we have to look at A and B and decide if either one of them is similar to the one with the red frame. So the first thing we're going to want to do is figure out what the ratio between the long and short sides on the rectangle that we're starting with is. So the ratio between the long and the short sides on this rectangle. Well, I know that opposite sides are congruent. So I know I have a 10 by 8 rectangular frame for this picture of this Dalmatian or whatever. I want to know what the ratio between the long and short side is. So it's just going to be 10 divided by 8, which is 1 1/4, 1.25. So what I need to do is figure out whether A or B, the picture in the blue frame or the picture in the green frame, has a ratio between its long and short sides that's 1.25. Okay, so the ratio down here under the blue picture between the long and short side would look like what? Well, the long side is 14, the short side is 12. 14 divided by 12 is going to be about 1.16. Okay, so that one's out. Now I'm going to do the same thing with the green frame picture. Ratio here, same thing between the long and the short side. So I'm going to always put the long side on top, short side on the bottom. Long side here is 15, the short side is 12. If I use my calculator and do 15 divided by 12, I'm going to get 1.25. We have a match. And so if this person, Kuma, wants to resize their photo of their dog, they're going to go with B rather than A. Second example, it says determine whether the triangles shown are similar. If so, write the similarity statement and scale factor. You don't have to explain your reasoning. We're just going to try and figure out if they're similar or not. All right, so first thing I have to do is figure out corresponding sides. Okay, so the clue I'm going to use here is I'm going to say that NQ has to be corresponding with RS, because NQ and RS are the two sides that connect the two angles that we have marked. Right? We only have two angles with any markings on them, and the one side on the big triangle that connects them is this NQ. So NQ is going to correspond with RS. So NQ, it says, is 12.5. RS is 10. Okay, I'm just going to go in order in both triangles. I'm going to go clockwise. So the next side I come to on the big triangle is QP. And the next side I come to on the small triangle is ST. So QP here, QP, and ST. QP is 11.5, and ST is 9.2. Okay, last pair of sides. On the big triangle we have PN, and on the small triangle we have TR. So if these two triangles are similar, it's going to mean that all three pairs of these corresponding sides have the same ratio. I'll write down the ratio for PN is 15 and TR is 12. So we have to do division on each of these problems to see if we come out with the same ratio. If we do, they're similar. If we don't, they're not similar. So 12.5 divided by 10, that's pretty easy. When you divide by 10, just shift the decimal point one place to the left. So that's going to be 1.25. 11.5 divided by 9.2. is also 1.25. So it's looking like they might be similar, but we can't say for sure until we compare the last two sides. Well, I know from back up here that 15 divided by 12 is also 1.25. So yes, these two triangles are similar. If I was going to write the similarity statement, I just have to make sure that I get the corresponding angles in the same order. So N corresponds with R, Q corresponds with S, and T with P. I guess it's P with T. And then I make the similarity sign between them and I'm done. Next example, it's telling me to start with that these two trapezoids are similar. So I'm not asking whether they're similar or not anymore. I'm being told they're similar and I have to find X. X is right here. X is on the big trapezoid. And so what I'm going to have to do is, first thing is figure out what side on the smaller trapezoid does X correspond with. And so that I don't get confused, what I've done right here is I've just taken the small trapezoid and I've just flipped it over so that it looks like the trapezoid on top. Okay, so like it's going to be easier this way, once I've done that, to figure out corresponding sides. Right? And I know that 10 corresponds with X. In other words, FD corresponds with YZ or ZY. Right? And I know that the length of FD is what I'm looking for. That's X. And the length of YZ is 10. Okay, but that doesn't really help me out. That's just telling me what I'm looking for. Okay, so what I'm going to have to do is figure out the scale factor here. In other words, figure out the ratio between sides on the big trapezoid and the small trapezoid. Okay, well, what I can see if I look at these two is that CD, this right side of the big trapezoid, corresponds with side YW or WY. Okay, and CD is 9 units long. WY is 6 units long. I know it looks like a 9, but it's because I flipped it over. So that should actually be a 6. All right, 9 divided by 6 is 1.5. So what I know now, the scale factor, if I want to multiply a side on the small trapezoid to get it to be the length of its corresponding side on the large trapezoid, I have to multiply it by 1.5. So in other words, 10, the side that corresponds with x on the small trapezoid, has to be multiplied by 1.5 to give me x. Right? If I want to go from this side that corresponds with x and make it big enough so that it's the same length as x, I have to multiply it by 1.5. So 10 times 1.5 is 15. So x in this problem would be 15. All right, last example before you start your homework problems. This one I have these two triangles, and I'm told that they're similar. So that means the ratio between corresponding sides is going to be the same for all three sides. I have to find what x and y are equal to. So what I did, this is not in your textbook, but I took triangle QST and I flipped it over so that it looks like triangle JML or JLM. The reason I did that is so that it makes it easier to see which sides correspond. And so I'm going to cross that out and put a 2 here, right side up, so it's easier to see. Okay, I need to find x, but before I do that, before I find x or y, I need to figure out what the scale factor is, or what the ratio, what I need to multiply each one of the sides on the small triangle by to get its corresponding side on the big triangle. And so I'm going to look at these two actually, and the only two sides that both have numbers that correspond are JM and QT. JM, it says, is 4, and QT is 2. 4 divided by 2 is 2. So I'm going to use this ratio of 2 to help me solve for x and y. So I'm going to do x first. Can go in either order, but I'm just going to do x first over here. Okay, the expression with x in it is right here, LM, and LM corresponds with ST. So LM is equal to 6x minus 3, ST is equal to 3. What I know about that ratio is that it has to be the same as the ratio between JM and QT. In other words, it has to be equal to 2. So what I'm going to do is I'm just going to solve this equation right here for x. So I'm going to rewrite it over here kind of small. First thing I have to do is get rid of this 3 down here. I don't want to deal with fractions, and so the best way to do it, since it's saying that I'm taking 6x minus 3 and dividing it by 3 right now, the way to get rid of that is to multiply both sides by 3. Okay, so those two cancel out. What I have now is 6x minus 3 equals 2 times 3, which is 6. I'm going to add 3 to both sides. 6x equals 9. I'm going to divide both sides by 6, and x is going to equal 1.5. Now I'll solve for y over here. We go back up to the picture, and the expression with y in it is on side JL. Side JL corresponds with QS. So JL, 3y minus 2, QS is 5. And I know that that ratio, again, has to be 2. So 3y minus 2 over 5 has to equal 2. Just like I did when I was solving for x, I'm going to multiply by whatever I'm being divided by to start with. So in this case, 3y minus 2 is being divided by 5. I'm going to multiply by 5 on both sides. So those two cancel. 3y minus 2 is equal to 2 times 5, which is 10. Add 2 to both sides. Those go away. 3y equals 10 plus 2, which is 12. Divide both sides by 3, and y comes out to be 4.